Lesson 9.2, Theoretical and Experimental Probability. In a uniform probability model, each outcome has an equal probability of happening. So experimental and theoretical probability. Theoretical probability is based on uniform probability. So what should happen when conducting a probability experiment? Experimental probability is based on relative frequency. So what actually occurs in your experiment? So theoretical is what should happen. Experimental is based off our experiment. Okay, so if we go down to the got it, letter A, it says refer to example 1. If the spinner was spun 3 more times and landed on green each time, find the experimental probability of spinning green for this experiment. Okay, so again, whenever we're finding probability, we always start with how many possibilities do we have? So what's the total number of possibilities? So if we go back up to example A, it told us that we had 60 total numbers of spins. Okay, now we just spun it 3 more times. So in our problem, we really have 63 times that we spun that spinner. Okay? And then our numerator is always how many times did that happen? So how many times did we spin green? Well, according to their first experiment, it was 21 times. And again, our example told us now we landed on it 3 more times, so we spun this 24 out of 63 times. Okay? So according to our experiment, it was 24 out of 63. Now remember, when you're working with fractions, we always have to simplify. So 24 63rds simplifies down to 8 21st. So we could say, based on this experiment, we spun a green 8 out of 21 times. Okay? Letter B says, compare the experimental probability you found in exercise A to its theoretical probability. So again, experimental probability is what happened in our experiment. Well, in our experiment, we spun the green 8 out of 21 times. Okay? And then we got to compare it to its theoretical probability. Remember, theoretical probability is what's supposed to happen. Okay? So we're just finding the probability here. So if we look at our results, we have 3 colors we can choose from, and one of them is green. So we would say we have 1 out of 3 chance. Okay? Now we need to compare those. Remember, when we compare, we need to have them in the same form, which could be decimals, fractions, or percents. And if we're working in fractions, they probably should be with the same denominator. Okay? That's easier to compare. 8 21st, 1/3, that's hard to think in our mind. So we could get these to common denominators. So we could leave 8 over 21, and we could change 1/3 into 21st. Okay, remember when you convert a fraction, 3 times 7 gives us 21, so we would take 1 times 7, which is 7. So if we were to compare 8 21st and 7 21st, we would say that they are close to each other, or about the same. Okay, so our experiment went just about as well as it should have. Okay? We turn to the next page, we look at example C. It says in example 3, what is the experimental probability of rolling a sum that is not 9? Okay, so now we want a sum that is not 9. So again, it's experimental probability is based off our experiment. They said that they rolled the cube 20 times, and the sum of 9 was rolled 8 times. So if we roll the sum of 9 8 times, we need to figure out, well, how many times out of that 20 was it not a 9? So if 8 consisted of 9, we would take 20 minus 8, and we would get 12. So we would say 12 out of 21 times, it was not a 9. Okay, again, when you're working with fractions, we always have to simplify. So 12 20th simplifies down to 3/5, because we could take a 4 out of both of those. Right? Example D, 2 coins are tossed 10 times. Both coins land on heads 6 times. Compare the experimental probability to the theoretical probability. If the probabilities are not close, explain a reason for the discrepancy. Okay? So first, we have 2 coins that are tossed 10 times. Okay? Both coins land on heads 6 times. So we're going to compare the experimental probability to the theoretical. So let's start with the experimental. Okay? So experimental is based on our experiment. Well, we flipped the coins 10 times and 6 of them landed on heads. So we would say our probability there was 6/10, because we landed on heads 6 times out of the 10 possibilities. Again, we need to simplify. We can take a 2 out. So 3/5 of the time, we landed on heads. Okay? Again, theoretical probability is what's supposed to happen. All right? So if we flip a coin once, the probability of getting a heads is 1/2. Okay, we need to do that again, so we're going to take that times another 1/2. So our experimental probability here is 1/4. Okay, now when we go to compare these, again, if we're going to leave them in fraction form, they need to have common denominators, or we can change them to a different form. We're going to change these ones to decimals. So 3/5 is about 6/10, and 1/4 is 25/100. So if we were to compare 6/10 and 25/100, we would say that they are not close. Okay? Our experiment did not go how it should according to our theoretical probability. So a possible discrepancy here is we didn't do it enough. Okay? We didn't have enough trials to really see how this experiment went. Okay, example E. Suppose 3 coins are tossed 10 times. All 3 coins land on heads 1 time. Compare the experimental probability to the theoretical probability. And again, if they're not close, we need to explain why. Okay, so again, I start with the experimental probability. What happened in our experiment? Well, we got all 3 coins landing on heads 1 time out of the 10 times we did it. So we would say our experimental probability happened 1 out of 10 times. Okay, then we go to our theoretical probability. So what was supposed to happen? So to find out our theoretical probability, when you flip a coin once, we have a 1/2 chance of getting a heads. Okay, then we flip it again, we have another 1/2 chance. In the third time, we have 1 chance. We multiply them all together, so we have 1/8. Okay, so our experimental was 1/10, our theoretical is 1/8. Again, now we need to compare these. It's hard to compare a 1/10 to an 1/8. Okay, so I'm going to change these into decimals again. So 1/10 would be 10th here, and 1/8 is 125 thousandths. So if I were to compare these, I would say that they are close. Our experiment went just about as well as it should have. Okay, so again, theoretical probability is what's supposed to happen. Okay, what is the probability that it's going to happen? Experimental is based off of your experiment.